Hello everyone, welcome back. This is Calculus 3. So in this video, we are going to talk about chain rule 4.5, chain rule. So a little bit of background. So in Calculus 1 and 2, we found out that one of the most useful differentiation rule is the chain rule, which allowed us to find the derivative of the composition of two functions, if you remember. So the same thing is going to be applied for multivariable calculus here, but this time we're going to deal with more than one form of the chain rule. Okay, so in this section, we're going to study the extension of the chain rule, and we're going to learn how to take derivative of compositions of functions when you have more than one variables. Okay, so let's take a look at the concept of the chain rule one more time. So recall, so the chain rule for the derivative of a composite of two functions, you can write it in the following form. So whenever you were dealing with the derivative and then you check the structure of the function, and then when you see that one of the function has been subbed into another function, we use a chain rule, which means you're taking the derivative outside and inside, and you multiply with each other. So that's the case when you are dealing with one variable of the function. But today, what we're going to do, we're going to use the same chain rule because you're going to see the composition of the function. But in this time, you will see, okay, you are going to look at two functions. So you see that you were dealing with one variable so that you took the derivative with respect to x variable. But now I'm giving you guys two variable x and y or u and v, whatever the, two different variable. And how would you be able to take the derivative of the function with two variable? Or if you have, function with three variable, right? So that's how we're going to talk about it. So one more time. Now we're going to suppose that f function, okay, f function of two variable, not one variable. This is, we are dealing with one variable in calculus 2, but now we are going to take more than two or three multiple variables, derivative, so that how would you be able to calculate the derivative of these cases? Okay. So the formula is actually given, but nobody gonna remember, right? So I will show you more visualized idea, and then I will come back to this formula. So let's look at this concept in a visualized idea. So we call tree diagram, okay? So look at that. I have a z function, which is f of xy. You are going to take the derivative of the function with two variables, x and y. So what happened is we have f, x and y. X has a function, let's say, x equal to x of t. So x is the function with respect to t variable. And let's say y is another function with respect to t variable, so that you have the function f, x, and y with two variables. So what happened is, think about the big structure is, you can think about it f, x, t, comma, y, t. So what happened? This is going to be the outside. You are going to take the derivative outside, and you are going to take the derivative inside. And then we have two different functions. So you are going to do a couple times of the differentiation. So let's look at the graph. I have a z. Okay, so let me change the color. I have a z equal to f of xy. So take the derivative, the z equation with respect to x variable first. One more time. You are going to take the derivative z equation with respect to y variable. You see that? So that's the two, that there are two different branch. One is you're taking the derivative with respect to x. Another one, you're taking the derivative with respect to y, correct? And then this is the outside function. This is the outside function. You took the derivative of the outside, and now this x has another, form of the function with respect to t. So what happened? The x equation. So the x equation, this equation, you're going to take the derivative of this x equation with respect to t variable. So that's how you're going to finish up with the x branch. So dz, the z equation, you're taking the derivative of the z equation, this one, with respect to x variable. And again, x function, you're going to take the derivative of the x equation, this one, with respect to t. So this is the one branch you can consider. The bottom one, you already took the derivative of the z equation with respect to y, and now you have inside, so y equation, you're going to take the derivative with respect to t. So you're going to multiply those two, and then the total answer is you're adding them up. Okay, so this is the inside derivative. This is the inside. This is the outside derivative. Does it make sense to you? So you took the derivative outside the z function with respect to each x and y. That's what happened. Then inside the x equation, you're going to take the derivative with respect to t. Y equation, you're going to take the derivative of the y with respect to t. So then you are going to the final answer. The answer is you are taking the dz, this one, with respect to dt. That means dz over dx, derivative times the dx over dt, plus dz over dy, y branch, dy over dt. This is a chain rule with two variables. Okay, so I'm going to highlight this one right there. This is the chain rule with two variables we are going to talk about for the rest of the slide. Does it make sense to you? So let's take a look at it. I'm going to copy this because we're going to keep utilizing. Copy. Okay, so that's why this formula, we just talked about it, right? So this is a chain rule with two variables when you're taking the derivative. So let's take a look at the example one. So likewise, let me go down, down, down. So this is the question. So we know this is the chain rule. So what are you guys going to do? We are going to take the derivative. So let's take a look at the format. The z equation is f(x) and y. You see that there are two different variables. So that is a 4x second plus 3y second. And then the x function has, another form of the function, which means the sine t has been subbed into the x. So this is the inside your function. So according to the chain rule, you have to find out you have to find out each derivative. So we are going to step by step. Let's find out the z equation, right? The z equation. You're taking the derivative with respect to x first, dx. So what happened? This is going to be dz over dx, 4x second, 3y second. It is going to be what? This is the partial derivative, correct? So you will consider y as a constant. It is going to be 8x, correct? Now we are going to do the y branch, the dy. So dz over dy, 4x second, 3y second. Now x is the constant, so that's going to be 0. So you should get 6y. Now what happened? Now you're going to take a look at the each x and y. So dx equation with respect to t. So what happened? Dx, dt, sine t. So what happened? Cosine t. And then now not dx, we have a y branch. You're going to take a derivative with respect to t. So dy over dt, cosine t will be negative sine t. So we found out each component, correct? Now what are you gonna do? You're gonna multiply, this is the X line, X branch. These are the Y branch. So finally, dz over dt, we are looking at this. The X branch, you're gonna multiply. What happened? dz over dx times dx over dt, dz over dt times dy over dt, correct? Uh-oh, I have a little bit typo. This one should be y, dz over dy. So we have all the information. 8x times cosine t plus 6y times negative sine t. So it is going to be 8x cosine t minus the 6y sine t. And then please make sure what happened. We know x is sine t, y is a cosine t. So you can plugging in x and y in terms of the t variable, because we are taking the entire z, we are taking the derivative of the entire z equation with respect to t. So you can plug in back 8 times cosine t times x, sorry, x was a sine t, so x is a sine t times cosine t minus y is a cosine t sine t. So they are same thing. The total answer is 2 sine t cosine t. So now your answer is with respect to t variable. So that's how you're taking the chain rule. That's how you're taking the derivative with the chain rule when you're dealing with the function with two variable. Does it make sense to you? Okay, so that should be fine. I think this is a beautiful work. All right, we're gonna keep practicing, applying the chain rule in the function of two variables. So let's take a look at the bottom example. I'm gonna keep utilizing the chain rule formula right there. So again, they're taking the z equation. You're taking the derivative of the z equation with respect to t. So we're gonna do all the thing, right? So first, dz over dx, x branch. So this is going to be x second minus y second. And then radical is a half exponent. So you're taking the derivative. This is going to be, what do you guys think? If you take the derivative, what happened? Let's think about it. This is going to be the partial derivative. So 1 over 2 x second y second, 1 over 2 minus 1, and inside, we are taking the derivative of the inside. This is the partial with respect to x. Y you can consider as a constant times 2x. So therefore, we have 2 to cancel, x times x second y second, negative 1 over 2. That is going to be radical x second y second x. So this is a dz over dx. Are you following? So let me minimize it. So be careful. This is another chain rule here. So let me highlight it. This is the outside. And then this is the inside, right? And then this is a partial derivative with respect to x. So outside and inside you can cancel. So that's what you got, dz over dx. Keep going. Now I'm gonna keep going to find out the next one. dz over dy, y branch. So therefore dz over dy, x second, y second, 1 over 2. Same thing, chain rule outside, 1 over 2 x second minus y second, 1 over 2 minus 1. And chain rule inside, now x is gonna be the constant, so you should get negative 2y. So cancel, 2. Again, this is y, x second, y second, negative 1 over 2, y over x second minus y second. So that's what I got. So far, so good. So this is x and y branch. And now you have to do the sub, the x function itself. So the dx over dt. So you are taking the x equation with respect to t. So what happened? This is a 2t. So if you remember, this is going to be what happened? You're going to bring 2 to the front, keep e to the 2t. dy over dt, so dy over dt, e to the negative t, so negative 1, e to the negative t. So we have all the information, isn't it? So finally, dz over dt, you have this guy, we have that guy. So I'm going to get rid of the pink line. So what happened? We have x over radical x second, y second. So this is the x branch. This is the y branch, correct? Times 2 e to the 2t plus y over x second minus y second, negative e to the negative t. Are we okay? So now I can combine them. So let me just minimize it. So this is going to be, if I rewrite it, 2x e to the 2t plus, actually minus because of the negative here. So that's going to be negative y e to the negative t, and then they have a same denominator, x second minus y second. You can stop here, but everything you can rewrite it with respect to t. So we know x is this, y is that. You're going to plug in back. So therefore 2x is what? E to the 2t. And then there's x. So actually, let me write it x first. So 2x, and then actually my bad. X is e to the 2t. So we have 2, and again, e to the 2t. Minus y is e to the negative t, and then e to the negative t over. X is what? E to the 2t to the second power minus e to the negative t to the second power. So let me minimize it. I'm going to minimize it. And then you can simplify the final answer. We have a 2 e to the 4t minus e to the negative 2t over, we have e to the 4t, because you're going to multiply 2, minus e to the negative 2t. This is the final answer with respect to t variable. So just be aware, this part, e to the 2t times 2, this is e to the 4t. Because e to the a, you're going to multiply them. So we multiply 2t times 2 is a 4t. So that's how you can finalize the answer, by using the chain rule when you're talking about the function with two variables. Okay, so practice is the best way to understand this concept. Okay, let's take a look at a couple more examples. Let me go down slowly. Okay, I'm going to put this formula one more time. I'm going to copy this and paste here. So here we go. We have a function z, okay, x and y. I see both equation. And then x is a given, y is a given. Oh, once you find out the answer, plugging in 0, because they want to know when t equal to 0. So step-by-step work. dz over dx, what happened? You are going to, take a look at the, partial derivative with respect to x. So it is going to be, y is going to be constant. So 2x plus 2y second. Am I correct? So this is going to be dz over dx. I think so. Let me double check. So that's what I got, right? 2x. And then what are you guys going to do? dz over dy. This is going to be now x is a constant. Oh, I have a bad mistake. Let me do it again. Let's do it again. So now you're taking the partial derivative respect to x. Y to the third is a constant. So y to the third, 2x plus y is going to be constant anyway. So 2 y second remaining. That's correct, right? Better. dz over dy, you're taking the derivative with respect to y. So now x is going to be the constant and then 3y second. X is the constant, 3x, and then 2y. So basically, it is going to be 2xy to the third, 2y to the second. This is going to be x second, 3 to the front, y to the second, 4xy. Are we okay? Now, dx over dt. What happened? So this is going to be sine t. So sine is going to be cosine. And then dy over dt, e to the 2t, 2e to the 2t. So we have this is the x branch. These are the y branch. So plugging in, dz over dx, dz over dt. So you're going to multiply this two, not that one, this one. So 2xy third, 2y second times cosine t plus 3x second, y second plus 4xy, 2e to the 2t. Okay, so now you're going to plugging in x and y in terms of the t here. So let's plugging in. 2 times x is what? Sine t. Y is e to the 2t to the third. 2 times e to the 2t. And then this one times cosine t. Plus, keep going. 3x is what? Sine t to the second. Y is e to the 2t to the second. Plus 4 times sine t. Y is e to the 2t. So we have that. Times, so let me minimize it. This one times 2e to the 2t. So we have changed it every xy in terms of t variable. Now here, that's your answer in terms of t, but now they want to know when t equal to 0. Plugging in, t equal to 0 everywhere. 2 sine 0, e to the 0 to the third, plus 2, e to the 0 times cosine 0. Plus 3 sine 0, e to the 0 to the second, 4 sine 0, e to the 0, and 2 times e to the 0. Because the t is a 0, when I'm plugging in, I simplify. What happened is, this is going to be 0. Sine 0 is a 0, so these are all 0. E to the 0 is 1. Cosine 0 is 1. So this is going to be in the first term here. You have 2 times 1 is 1 plus, and then same thing, sine 0, these are all 0. Sine 0, these are all 0. So everything is a 0 here. Although you have a 1 times a 0 is a 0. So 0, so your answer is going to be 2 when t equal to 0. Okay, so that's your final answer. How you feel? I like this type of question. I hope you like it too, right? So we'll keep practicing the, taking the derivative with the, multiple variable. So especially we have a 2 variable here. So let's do one more applicational problem. So let me read it slowly. Let's think about it. The radius of circular cylinder. So that's what the shape look like. And that is decreasing by 1.2 centimeter per second. So they are decreasing. And its height is increasing at a rate of 3 centimeter per second. So what's going on? In this sentence, the radius is decreasing. So the radius is decreasing with respect to time. As the time goes on, the radius is decreasing, so equal to negative 1.2. So that's a given, I'm just explaining. But at the time, the height over the time, they're going to be increasing 3. So this is a given. Are you following? So you can think about it. The radius decreasing over time. Height is increasing over time. So dr over dt is negative 1.2. It's a decreasing. Height is increasing over time every 3 centimeters per second. They want you to find out the volume. So especially when radius is 80, when height is equal to 150. So the given dr over dt is negative 1.2. dh over dt is 3. R equal to 80. H equal to 150. We are looking for the volume, dv over dt. What are you guys going to do? The dv over dr over dt plus dv over dh height dh over dt. So we are talking about the volume. The volume equation is what? Radius and height components. So the volume is going to be changing depending on the radius and height. So this is the exactly function of 2 variable. So I have to, you can think about it, this is the volume over t. So the volume, take the r branch first, and then h branch, second. And then r is going to be changing over time. H is changing over the time. So that's, you can set it up. So we have all the information, dv over dr. And then dv over dh. So we have to think about it. dv over dr, dv over dr. So first of all, we have to have a little bit of prior knowledge. The volume of cylinder formula is a pi r second h. So this is the volume is r comma h, 2 variables. So take a look at it. This is actually the volume, v equal to pi r second h. So now you have dv over dr. What is it? Now h is a constant, pi is a constant. So 2r pi h. dv over dh. What happened? Pi r second, they're going to be constant, h is going to be 1. So you have to think about this first, okay? And then we're going to plugging in. So dv 2r pi h. And then I know dr over dt from our given, negative 1.2. And then dv over dh, we have a pi r square. And then dh over dt, that is a 3. And then we also know what the r and h plugging in. So 2 times 80, pi times 150, negative 1.2. Pi 80 square, 3. So once you're plugging everything, you should get negative 9,600 pi. This is the volume. Volume is going to be decreasing over the time. So this is volume over the time. Volume changes over the time. So that's how you think about the chain rule in the applicational problem. Okay? So a little bit of tip, because we need to know what the volume formula are. So you're going to start from here. You can find out the R branch and H branch, and then dr dt is a given so that you can plug in the rest of information. All right, so that's pretty much how you take the chain rule for 2 variable. Now we're going to do a little bit complicated concept. Are you ready? Okay, here we go. So far we talked about the basic chain rule for two variable. Now I'm gonna do the similar question, but the title say, we're gonna take the chain rule, same chain rule, for two independent variables. So what happened is, now we know that we talk about z equal to f x or y. So if you have, let me just write it again. Let's say z over t equal to, we just talked about this. Right, so this is literally, you take the formula, if you remember, this is how we did it for this case, right? But now what happened is, your x and y has also two variable. That's a difference. So what we're gonna do, let's say we have a z of t, and you have x is something in x function. We don't have not t, but we have also u and v, let's say two variable. Y also has a two variable. So this is a different from we talked about the first scenario, right? We talk about, so when you talked about the first case, both of them we're talking about the two variable. Both of them we're dealing with two variables, but the first case, you have only one variable that you're taking the derivative inside of the x and y. But now what happened? Inside of the x and y, you have another two variable going on. So it looks like a more complicated situation, isn't it? So here is the tree Venn diagram that I'm going to share with you. So here we go. First, the outside is the same thing. So you have the z. So take the z equation with respect to x. Take the z equation, derivative with respect to y. So that's so far so good. Now your x function has another two variable u and v. So what happened? The x equation is going to be, extended with two different branch. One is a dx over du, dx over dv, correct? So this is another branch from the x. Same thing, y, you have another u and v. So we are going to go to dy over du, dy over dv. So what happened? This is the dz over dx, and then x branch go to u. So this is going to be dz over dx times dx over du. This means dz over du, okay? But the next one here, this is, you're gonna go to v, right? So you're gonna go to x and then you're gonna go to v. So this is the thing. So it means the dz over dv, okay? Keep going. Let's observe the bottom, y, but then you're gonna go to u, right? At the end, you're gonna go to u. So this is going to be another dz over du. Last one, you're gonna go to v, and then this is going to be dz, this is going to be dz over dv. So what happened is, the two variable, okay, we just talked about it. I'm gonna write it here. So here, you're gonna adding the yellow together. So the yellow, this is a u family, u family, u family. So dz over du, dz over dx times, right? And then dx over du plus dz go to dy, the yellow, times dy over du. You are actually reaching out to the u variable at the end. So this is a dz over du. And another branch we found out, dz over dv. So dz, first x, and then dx over dv, dz over dy, dy go to dv. So at the end, you're going to the v. So this is dz over dv. So this is, we call chain rule of two independent two variables such as z equal to x uv comma y uv. Does it make sense? So this is a differ from, we just talked about dz over dt, dz over dx, dx over dt, dz over dy, dy over dt. This is chain rule of two just simple variables, which means z equal to, you have x, just t, one variable. But here, that's a difference, right? Here we have a two variable, but you have only one variable. So that's a difference between these two formula. Please make sure. So I'm gonna show you the second example, this one. Okay, we're gonna take a look at the example of chain rule for independent variable, two independent variable. Okay, please make sure they're different. So let's take a look at example 3 or 4. So let me go down slowly. So take a look at the difference. Here we go, example 5 actually. So let me paste it here. So this is what we're doing, okay? All right, so what we're gonna do, we have to do all the step-by-step work. Let's find out. So in this time, z equation is e to the x times cosine y. So you have x and y here, but then x is going to be another. X has another s and t. Y has another s and t. So this is exactly two independent variable case. So we're gonna do all the each case. So the dz, in this time, you're gonna go to s and t, ds, what happened? dz over dx times dx over ds, and then dz over dy times dy over ds. This is S family. And then you have dz over dt. So dz over dx, dx over dt. And then dz over dy, dy over dt. Are you following? So this is S, this is t. So we have S and t variable. So now we're gonna do all the work. So dz over dx. So here you're taking the partial derivative with respect to x. So cosine y is a constant. E to the x is the same thing. So e to the x cosine y. And then dx over dt, t is gonna be the constant. So it's going to be t to the second. And then dz over dy, you're taking the derivative. So e to the x minus sine y times dy over ds. So s is gonna, t is gonna be the constant. So 2st. So we have that. So if you rewrite it, t second e to the x cosine y and minus 2st e to the second sine y. So this is what we got, dz over ds. Let's look at the next one. dz over dt. So this one, dz over dx, we already know, e to the x cosine y times dx over dt. So now dx over dt, tx 2s, and then s is the constant. So you have a 2st. dz over dy. So we know this is e to the x minus sine y. And then dy over dt. Now s is the constant, so we have only s to the second. So if I rewrite it, 2st e to the x cosine y, and then s second e to the x. Actually now this is going to be negative because we have a negative sign, negative sine y. So this is your two answer by utilizing the chain rule when you have two independent variables. Okay, so that's how you write it. You don't need to adding, no, there's no adding, just separate it, evaluate it dz over du or dz over dv both. Got you? Got you, got you. So that's the case. I think it's getting better and better, correct? So, I mean, now you can practice more. Example 6, right? You can take a look at it. It's not really difficult at all. You can handle this question, right? So maybe you can practice this one, okay, later. And then, you know, plugging in S is a 2, 0, so your answer is going to be very simple. So I already show you how to utilize the chain rule when you have a two independent variables. So try this one. Okay, you should be okay. Now, what I want to do, I'm going to do the next one. Very, 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 looks like a complicated, but actually not. So let's look at that. So, so by observing, we took the z equal to x t y t. We took the x uv y uv. So we've been observing how to take the chain rule for each case. So by observing this, even though you have a multiple variable such that, you know, you have a w, let's say inside there's a multiple, like a not only uv, but you have a multiple. It's not scary. You know what to do. Just a little bit like a more branch, more branch. But we are not going to do more than 4 or 5. I'm going to just to show you, what if we have 3 variables? So for example, let's say z equal to f, simply this one, this one, this one. How about that? Okay. And then I'm gonna actually make it simpler. Actually, let's say I'm gonna do more multiple variables. We're gonna extend it. So what if I have z equal to, let's say we have xyz, and then x is going to be x. There's a 3 variable tuv, and y also has 3 variable. So this is going to be very complicated, you feel like, but actually not. I will show you. Okay, let's say we have this scenario, multiple variables from above the observation. We know how to do those two. What if we have this multiple variables? Okay, step by step, just let's make a Venn diagram. Okay, I'm gonna make a little bit smaller. So we're gonna make a Venn diagram. So step 1, z equal x, y, z. So from here, you're gonna have 3 different branch. 1, which is dz over dx. And then second one, you have dz over dy, isn't it? The last one, you have dz over dz. Actually, let's change this one, w, because the dz is overlapped. So let me change this one. Let me change this. Let's say this is a w. That's a better. So let's say w. So w, d, w, you're going to take the derivative with respect to x, with respect to y, and the last one with respect to z. So that's, you have 3 different branch. Now, what do you guys think? Here, you're going to go, but here x is u, actually t, u, v. So that's why you have another 3 branch. One is dx over dt, dx over du, dx over dv. Am I good? Here, same thing. We have y has a 3 variable t, u, v. So dy over dt, dy over du, dy over dv. Better? the last one, you have another 3 branch because Z has also 3 variable. So dz over dx, dt, dz over du, dz over dv. So what is your final? This one, you're going to multiply this one times this. So dw times dx times dx over dt. And then keep going the next one. dw dx times dx over du. And then dw over dx times dx over dv. Keep going. What happened the next one? Let me just minimize this part a little bit. This one, dw over dy times dy over dt. dw over dy, dy over du. This one, dw over dy, dy over dv. Keep going. What is the last part? dw over dz, dz over dt, dw over dz times dz over du. The last one, dw over dz, dz over du. Now what happened? Are you going to stop here or what? So take a look at it. This is the U. First of all, you have to make the case T family. So this is the T family. At the end, T. At the end, T. At the end, T family. And then what happened? Another one, we have a U family. U family, U family. Last one, we have V family, V family, V family. I have a little bit of typo. This one should be B, not U, correct? So let's change that one, V. So that's your old family. So now I'm going to combine all this founding. So what happened? We have 3 formula. There are 3 formulas like we found out here. We have a 2 formula. We have a 1 formula. We have a first dw go to dt family, which is all the blue family. dw dx times dx over dt plus dw over dy times dy over dt. And last one, dw over dz, dz over dt. So this is the dw over dt. And then we also find out the u family. So dw over d u, right? So what happened? We have all the this green family, dw over dx, dx over du, dw over dy, dy over du, dw dz, dz over du. Last one, we have a dw over dv family. So that is a dw over the older one, the thick green family. So dx, dx over dv, dw over dy, dy over dv, dw over dz, dz over dv. So that's how you're going to find out those are 3 formulas from 3 variables. Okay, so I'm going to take a look at one more time. I'm going to highlight it. So this is the first case we talked about it. Second case, the 2 independent variable, and this is a 3 variable you have. Okay, so this is the Venn diagram, so you can think about it and you can calculate it. So in terms of this, let me show you the example. Are you ready, 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 ready? So let's do this example. I'm going to go down. So let me copy this, copy here. So we are going to this example. So what happened? We have a W is 3 variable, which is this equation. And we have also x, y, z. We have another uv, uv. So in this time, what happened? We are not going to have all this 1, 2, 3, 4, 5, 6, 7, 8, 9. They're going to be much simpler because we used to have 3 variable here, but now we have only 2 variable u and v. So if you draw the Venn diagram, let's do it. W, x, y, z. We have dw over dx, dw over dy, dw over dz. And what happened? Here, the x has a u and v, so dx over du. And we have dx over dv. What happened here? We have y has also u and v, so dy over du, dy over dv, correct? Last one, we have z has also u and v, so dz over du, dz over dv. So what happened? You have only 1, 2, 3, 4, 5, 6 combination, which is this one, dw over dx times dx over du, dx over dw. So this one we're going to multiply from the beginning. So dw over dx times dx over du. This one dw over dy, dy over du, dw over dy, dy over dv, almost dz over dw, my bad. dw first, dz times dz over du. And then we have d w over dz, and then dz over dv. So what happened? Same thing, you have U family. This is all U family. And then you have another V family. So I have a little bit, this one should be V. Why it look like a U? This one should be V. So this is a V family. Right? So what happened? We have a 2 equation. dw over du. Let me write it better. du, dw over dx, dx over du, plus dw over dx, actually dy, times dy over du, dw over dz, times dz over du. And then another branch is a dv, v ending. So dw, dx times dx over dv, dw, dy, dy over dv, plus dw over dz, dz over dv. So you have this. So to solve this problem, you need this Venn diagram. So this is a different. So the above one, this one, when you have x has a t, we have a 3 variable, t, u, v. Y also has a t, u, v. The z also has a t, u, v. This one, we have x has only 2, u and v. Y has a u and v. Z has a u and v. So that's why above Venn diagram, you have a 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have a 3 equation. In the bottom, we have only 1, 2, 3, 4, 5, 6, and you have a 2 equation. So take a look at the Venn diagram, how many variables you have, depending on that, right? You have a different Venn diagram. So take a look at those each 3. Let's do the problem we are doing it. So we have a formula. This is what you're gonna do to do this problem. So let's step by step. Let's do each one. So d w dx, what happened? Here, this is the equation. So y and z, that's gonna be the constant. So 6x minus 2y is the constant, and x is gonna be 1, and that's the 0. And then let's do the next one. dw over dy. So now you're taking the partial derivative with respect to y. X is going to be the constant, so dw over dy. So what happened? dw over dy. So 3x a second. That's going to be the constant. And then we have 2x. That's it. And then we do have plus 4z to the second power. Am I correct? I have a little bit of typo. So when you take the partial derivative dw over dx, okay, this is a 6x. And then, okay, the 4z, there's no, x, so that's going to be 0. So same thing, I made a mistake here. This is going to be 0. Z is going to be the 0. So here, this is the constant. So constant is going to be 0. The constant will be 0. So we have only 2x. Am I correct? So partial derivative, last one, dz. So 3x a second going to be 0. Negative 2xy will be 0, 8z. So we found out the big branch. Now you're going to find out the small branch. dx over du. So here, in the x equation, you're going to take the partial derivative with respect to u. So e to the u. And sine v, that's kind of like a constant, keep it. Now, next one, dy over du. So dy equation, so you have e to the u cosine v. And then last one, dz over du. What happened? Just e to the u. Keep going. dx, now dv. What happened? V, so e to the u is a constant now. And then sine gonna be cosine v. dy over dv. E to the u is constant, cosine v will be negative sine v. dz over dv, it's going to be 0. So we have this information. Are you following? So this is all you need, right, to find out each one. So now let's do this first one, copy. So what happened? Plugging in. We have everything. dw over dx, 6x minus 2y times dx over du, e to the u sine v minus dw dy, negative 2x times dy over du, e to the u cosine v, plus the last one, 8z times dz over du, that's e to the u. So I'm gonna combining everything. I can see the common like term, e to the u, e to the u, e to the u everywhere. So let's bring them all front. So before we're gonna do it, can we do the distributive property first? So 6x e to the u sine v minus 2y e to the u sine v, 2x e to the u cosine v, 8z e to the u. Again, like now you have e to the u, e to the u, e to the u everywhere. And then again, 2 is another common factor. So what I'm going to do, 2 e to the u factor out. So the remaining 3, x sine v minus 2, you took it out as a factor. So y sine v remaining minus x cosine v plus 4z. So this is going to be, right? This is going to be our final, but then now, whatever x, y, x, z, we know what that is. So we're going to plug in back x, y, z. So that is going to be 2 e to the u. X is what? If you go up, x is e to the u sine v. I have another sine v. So this is x minus y e to the u cosine v cosine v. So this is y. 4z e to the u. Again, you have another e to the u, factor out. So 2 e to the u, another e to the u. So 3 sine second v, correct? Because we have a 2 sine v minus, we have, what happened? We took it out and then cosine second v. And then we are going to have plus 4. So let me double check if I have any mistake somewhere. So 2x da 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 da, we have that. And then we have, I'm missing something. So this is a 3x, this one. Oh, I see. This is the y. I'm missing one of this. So let me just go back. Let me just get rid of it. So from here, x is e to the u sine v. And then we have y e to the u cosine v. And then I forgot this one. You see that I forgot this. So let me adding that one there, right there. So we have minus x is e to the u sine v cosine v. So let me minimize it. And then plus 4 z e to the u. Okay, that's good. So now you have e to the u anyway. Find out the common factor. So 3 sine second v cosine v cosine. 1 second. So we have a y. Y was what? Cosine v. And then we have a sine v. So let me change this one sine. My bad. And that's better. So this is, again, this is x, this is y. This is x, this is z. So you can see, so now it is going to be cosine v sine v, and then sine v cosine v 4, because I took it out e to the u. So finally 2 e to the 2u, correct? And what happened? They're going to be same thing. 3 sine second v, right? Minus 2 cosine v sine v minus, actually plus 4. This is the one answer, which is this one. We are not done yet. You know what to do, the second one in terms of the v. So copy, let's finish. So if I'm just minimize a little bit, oopsie, I'm gonna minimize a little bit because I need a space. And then we are going to paste. So we're gonna do the second one. So you have all the information. Plugging in, we already have that. So that is going to be dw dx, we know, 6x minus 2y dx over dv this time. So e to the u cosine v. And then this is a 2x dw dy, dy over dv e to the u sine v. So I'm just plugging in. We know each component, we have all of them here. So you can get it right there. So I'm just writing everything dw dz. That would be 8z, and the last one we got 0. So this is 0 anyway. So let's do distributive property 6x e to the u cosine v. So this is a v, right? And then minus 2y e to the u cosine v. And then 2x e to the u sine v. So again, I have e to the u, e to the u, e to the u everywhere. And 2 is another common factor. So 2 e to the u, so 3x cosine v, y cosine v, x sine v. Again, you can plugging in x, y, z in terms of what? In terms of the given u and v. So if you're plugging in 2 e to the u, 3, x is what? E to the u sine v, and we have a cosine v. Y is e to the u, cosine v, cosine v. X is e to the u, sine v, sine v. So if I'm simplifying, what happened? Another e to the u. So 2 e to the u, 3 sine v, cosine v, cosine second v, sine second v. So the final answer, 2 times e to the 2u, so 3 sine v, cosine second v, sine second v. So that's your answer, dv over dw. So let me minimize it. Then actually I'm gonna get rid of this paper. Okay, so that's how you do the 3 multiple variable. So I show you all the work. So this is the last, multiple variable you need to practice, okay? And think about this one as well. We didn't do this example, but you can think about this tree Venn diagram and you can apply it into any question. So in this video, we solve a very, very, comfortable question. I hope so. So you can take a look at this. What happened? So you have a u, x, y, z, and what happened? X has RST. So this is exactly y has RST. We also has a z has RST. So what happened? You're gonna use this one. I'm gonna copy this. You're gonna literally do this example here. No, not there. I'm gonna get rid of delete. So here, add page. So this is exactly this example. You're gonna utilize that table. So I'm gonna get rid of it. This one. So this is exactly what you're gonna do. You're gonna have 3 equation, right? This is a 3, and practice this. And if you go up, we had a 3 equation. Do you remember this? Copy. So try this example. You will get 3 answers of, from the 3 formula. So this is try. I want to do this one, but I want you guys to try first. Okay. I'm not going to do all problem. You need to practice so that you can have a better understanding on what you're doing, right? So this is exactly, you will have 3 equation because we have 3 variables in each x, y, z. So try this and take a look at it. If you have any question, feel free to post in our discussion board always. And then now you have a better concept. You can finish your 4.5 quiz. Okay. So you guys have been doing awesome. You guys have been working so hard. Keep on doing it. I hope this video is helpful for you to, develop the concept. And if you have any question, email me. Otherwise, I will see you guys in the next video. I will see you guys soon. Bye-bye.